We just finished looking at PEMDAS, at order of operations. What order do we do things in and evaluate our expressions? Now we're going to be looking at simplifying things down as much as possible because, we want things to be simpler. Why wouldn't you want to make things simpler? So we're going to simplify our expressions down as far as we can before we start to work with them. So we're going to be using commutative, associative, distributive properties to simplify these expressions, combine like terms. And we're going to have 2 videos on this. So the first thing, different properties, commutative. Commutative, kind of like you commute to work, or your parents commute to work. You commute to school. You go from one place to another. Do the same thing every day. You commute to school. So you go from your home or wherever to school. The commutative property allows us to, commutative property allows us to essentially flip-flop. Sometimes I may say flip-flop. 2 and 7. 2 plus 7 is the same as 7 plus 2. 9. 3 times 9. We can flip-flop those around and have it be the same as 9 times 3. So addition and multiplication have a commutative property, which says that we can flip-flop the numbers and get the same result. So the algebra, the algorithm, the overall way, the general way of saying it is A plus B is equal to B plus A. A times B is equal to B times A. Now that does not work with subtraction. 2 minus 5 is not equal to 5 minus 2. However, we can manipulate things a little bit to make it work for us. That's part of math, is manipulating things, making it work. So it doesn't work this way, but I want it to, and I'm important, and so I'm going to make it work for me. I'm going to change this. Instead of 2 minus 5, let's make it 2 plus negative 5. Change. And 5 plus negative 2. So 2 plus 5, not 5 plus negative 2, 2 plus 5, 2 plus negative 5 though. 2 plus negative 5, that I can flip-flop around. I can't say that 2 minus 5 is equal to 5 minus 2. That is definitely incorrect. I can't do that. But 2 plus negative 5, that's the same as negative 5 plus 2. That I can do. So if you really want to switch that 2 and 5 around, you can't just change it to from 2 minus 5 to 5 minus 2. However, if you can change 2 minus 5 into an addition problem, 2 plus negative 5, now I can use that commutative property and say that 2 plus negative 5 is the same as negative 5 plus 2. I get negative 3 both ways. And so you can't just flip the numbers around with the subtraction sign, but you can manipulate things and say that 2 minus 5 is the same as negative 5 plus 2. And you can use that addition then to manipulate. But that's something you can do or not. Okay, associative property. Associative property is just who you associate with, who you talk to, who you communicate with, who you hang out with. So the associative property here, 6 plus 8 plus 2 is the same as 6 plus 8. They're friends today. 2 is kind of on the outskirts there. They're no good. But the next day, 8 plus 2, they're good buddies, and 6 is on the outside. And so the associative property is just how do we group things. Those are different properties we'll use. Mental math. We're going to use this distributive property and associative property to do some mental arithmetic. Rather than writing things out and working it out just by writing things down, we're going to try and use these properties to help us work out problems easier in our head. Here's an example. 1/3 times 5 times 33. If I were just to go from left to right and say, well, 1/3 times 5 is 5/3 times 33 and get some really big numbers to work with, there's an easier, faster way. If I use the commutative property, I say, well, 5 times 33 is the same as 33 times 5. We'll see why I do this. So instead of the first written way, I just flip-flop those numbers. I use the commutative property to change those numbers around. Now, 1/3 times 33, that's a little easier to do in my head. Divided by 3 is the same as 1/3. 1/3, that's the same as divided by 3. 1/3 times 33, that's 33 divided by 3. 33 divided by 3 11 times 5 is 55. 1/3 of 33, 33 divided by 3 gives us 11. So that's a much easier thing to do in my head. So using that commutative property allows me to do things in my head a lot easier. This takes a lot of practice. So what I want you to do is I want you to look at this next problem, identify what things you think should be right next to each other, what things would be easy to combine together in your head, and just tweak it a little bit. Change the numbers around. Use that commutative property or that associative property to work with it. So try this one on your own. Write it down, try it on your own, pause it, and see what you can get. I'm assuming you tried it on your own, I'm assuming you paused it. The correct answer for this one is 20. If you did not get the answer of 20, make sure that you watch the linked video or watch example number 1 below and see how it's done. Okay, distributive property. We use the distributive property all the time. It's a very important thing. Not only is it important in math to simplify expressions, but it's important for money. Whenever the government wants to distribute money, we use a distributive property to figure out how much money to give to different groups of people, different cities, different communities. So this distributive property we use a lot outside of mathematics as well, outside of the math classroom. So in distributive properties, we have parentheses. This is 3 times 4 plus 8. Rather than doing 3 times 12, we can see that as 3 times 4 plus 3 times 8. So you're thinking, well, what's the point of that? It's way more work. Why would we do such a thing? If you had something like 3 times x plus 4, well, we can't do x plus 4. We don't know what x is. Well, how can we get the x out of the parentheses to figure out what it is? And that's where we can use this distributive property to say, well, 3 times x plus 4 in parentheses is the same as 3 times x plus 3 times 4. And it works out. 3 times 12 is going to be 36. And 3 times 4, we have 12 plus 4. Oh, no, sure enough, 36. So it does work. And in general, we would say that A times the sum of B and C is equal to A times B plus A times C. An example of how we can do that in mental math. And this is something some of you maybe already do, but it's a great way to multiply. I do this all the time when I'm multiplying, if we're trying to multiply in my head. If I'm going to do 5 times 59, I'm not going to set it up as 59 times 5 and just do the algorithm from there. I'm not going to use that method. I'm going to do it in my head. So well, that's the same as 5 times 50 plus 9. Because 59 is 59. 50 plus 9, 50 and 9. I can do this a lot easier. 5 times 50 is 250. 5 times 5 is 25. 5 times 50 is 250. 5 times 9 is 45. Those are two things I can do quickly and easily in my head. So if I add those together, I'm going to get 295. That's something I can comprehend, or I can compute mentally. And really, we're looking at trying to do things mental math. We're trying to figure out what's called partial sums. But 50 times 59, rather than doing the standard algorithm over here, look at it as 50 plus 9. 5 times 50, 5 plus 9, add it to 295. So what I'd like you to do is on the next page, you have 2 examples. I'd like you to, and I actually do need you to write it out, even though it's mental math, I get that. But I do want you to write it out. I want you to expand what's inside the parentheses. Instead of 59, put 50 plus 9, or whatever the number is, and then distribute through the parentheses. We're practicing this process. Distributive property is going to be extremely important. It's going to be a key role in the next couple of problems, in the next chapter. It's very, 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 very important to get practice with this distributive property. So write these out using the distributive property. Don't write this down as 52 times 9 and work it out from there. Don't do that way. I'd like you to do it the other way with this distributive property, the partial sums, to get the answer. I'm assuming you paused it, so you can try it on your own. If you haven't done that, pause it, try it on your own first. It is important that you try something before I write down the answer. The correct answer for this one is 460 feet. The correct answer for the second one is 264. If you didn't get those answers, watch the linked video. This will be example 2. Watch the linked video at how to get those 2 answers. Last little bit here, we're going to be talking about how to simplify, how to get things simpler. So we got some vocabulary. We're going to write down, these are like terms. They are like. They both have an X. So these are like terms that we have. I'm going to try and hurry up here a little bit. They both have an X, so they're alike. And then we have, here we go. There we go, constant. Constant has no X. And the numbers that are before the variables, we call coefficients. So pause it, write those numbers down. So we're using the same language, we're using the same terms. We've got like terms, we've got constants, we've got coefficients. I'm going to use those terms to describe things as we go through the next couple slides. So I want to make sure that we're using the same vocabulary. We're simplifying expressions by combining like terms. First, we have to identify if they are alike. So by finding those like terms, we're looking for the variables, the p and the p. They are both p's, which means that we can combine them together because they're alike. You got 72 p's, you got 25 p's, which means we can combine these p's and these p's together. P's. So if we do 72 p's minus 5 p's, we're going to combine those together and say, well, I've taken 25 of my p's away. It's very awkward talking about this, but it works. And I'm going to end up with, what, 25, 5, my brain just kind of went, so let's just write it out. 72, when your mental math isn't going the way you want it to, write it out. 72 minus 25, tomorrow, and I'm going to end up with 47 p's in the end. So it's just combining, we're not solving for p. We have no idea what p represents. We just know that if I have 72 p's, I take 25 p's away, I'll have 47 p's left over. Same thing with the next one here, 3/4 x to the 4th plus another x to the 4th. So these are both x to the 4ths, which means that we can combine them together. They're both the same variable, they are like terms. And we look at the coefficients. Here are the coefficients for 72 and 25. Now the coefficients are 3/4 and something. There's no coefficient there. What ends up happening is if there's no coefficient, there really is a 1 right in front of that x to the 4th. We don't often write it, but there is one x to the 4th there. I can see it. There's an x to the 4th. There's one of them. And so the 1 is not always written, but there's always a coefficient. 1 if we don't write it. So we have 3/4 x to the 4th plus 1 x to the 4th, which gives us 1 3/4. And that's what the combined, simplified version of this would be. 1 3/4 x to the 4th. That's how many x to the 4ths there are. Try these 3 on your own. Pause it, try them. I'm going to put the answers. If you don't get the same answers as me, watch the linked video. Okay, for the first one you should end up with 100 p's. For the second one, we can't combine them together. So you should end up with -20t minus 8.5 t squared. And for the last one, again, not like terms, which means that we cannot combine them together. We're just stuck with 3m squared plus m to the 3rd. On a test or a quiz or on a book assignment, I am going to ask you to rewrite it, and don't just put can't. Because it is simplified. So simplify, that's as simplified as it gets. So that should be your answer for these 3 here. Go ahead and answer the questions in the assessment below, and we'll talk to you in class.
And